back, all my aspiring mathematicians. I'm going to show you some quick and easy tips to solve and graph linear inequality. Now, what is linear inequality? Linear inequality is an expression. And that linear inequality, it involves a linear function. Linear inequality contains one of the symbols of inequality. And the four symbols of inequalities are greater than, less than, greater than or equal to, and less than or equal to. Sometimes a linear inequality is given to you in one variable, and that is what it's going to look like if it is ax plus b greater than 0. That's the one variable form. The two variable form would be ax plus by less than or equal to c. And this is what we call the two variable form. Let's learn about the four inequality symbols. So you have less than, and you have greater than, and you have less than or equal to, and greater than or equal to. Now, what I must say to you is that there are certain things that you need to know before you start graphing a linear inequality. You need to know about the boundary line, which one to use, and you also need to know about shading. There are two types of boundary lines. You have the solid line, which looks like that, and you have the dashed line that looks like this. This is all based on the inequality symbol. For a solid line, you are either going to use greater than or equal to or less than or equal to. It must have half of the equal sign underneath that inequality for you to use a solid line when you are graphing your inequality. And for a dashed line, it's either going to be a less than or is going to be a greater than symbol. Now, in terms of shading, if you have greater than or greater than or equal to, you're going to shade above or to the right. And if you have the inequality symbol, which is going to be less than equal to or less than, you're going to shade below or to the left. So there's something that you need to know about inequality. If you have a negative in front of that y or x and you have an inequality symbol, you must do something very important to it before you can start graphing it. So say, for instance, if you're given us a problem like this, say 2x minus y less than or equals to 3. You cannot just go ahead and graph this. You have to first just get y by itself. Y is not by itself now, and in order to write y by itself, you have to get rid of the 2x here and bring it onto the other side. So I'm going to do the inverse, which is minus 2x, and whatever I do on one side, I must do it on the other side. So now you will end up with negative y, which is less than or equals negative 2x plus 3. But this is not acceptable. You need to get rid of this. Even if it was a whole number that is greater than 1 in front of it, you still have to do something where this you're going to treat it as an invisible 1 here. So you're going to divide by negative 1 and you're going to do it with both sides. But you must change this. So you will now have y, but you're going to change that inequality symbol to the other one equivalent to it or opposite. You're going to change the inequality symbol from less than or equal to greater than or equal to. And then negative numbers here is going to give you a positive number. So it's 2x minus 3. The same thing will apply even if you didn't have it in this form. Even if you had negative x greater than 5, you must change this, because you cannot go ahead and now graph that. So you will have to change that. You will also still have to divide by -1 on both sides. Once you do that, you will end up with x, but you must change the symbol, which is now greater than to less than, and you will have -5. So this is what you have to do first once you are given these type of scenarios. So with that being said, I am going to demonstrate to you how to graph linear inequality. So the first one I'm going to graph here for you is x is greater than -5. So I have my -5. You have to look on your x-axis and you find -5 is here. So the first thing that you need to take away from this is that you have greater than symbol, so you need a dashed line. Since we know that our inequality is x is greater than -5, we are going to find that -5 on our x-axis, and we are going to use our dashed line in this case, and this is a vertical line. Then we have to look at the inequality symbol and determine if we're going to shade to the right or to the left. Because it is greater than, we are going to simply shade to the right. So we are going to shade to the right. So we're going to shade anything to the right over here. And this is what it's going to look like. Choose any point in the shaded region, and I can choose this point, which is 1, -2. And that will make the solution true anywhere within the shaded region. Now this is not all. I'm going to show you another example because you know I like to give you various examples, and I'm also going to graph this inequality for you, which is y is greater than or equal to 2x minus 3. We still have to find our slope, and our slope here is 2, and our b value here is -3. So we're going to look for the coordinate of 0, -3 to start. I'm going to start at 0, -3, which is here, and I'm going to go up 2 over 1 for the slope, up 2 over 1 for, or down 2 to the left 1 for the slope, or down 2 to the left 1 for the slope. This symbol, which is the greater than or equal to symbol, is telling us that we need a solid line. And also, in terms of shading, we need to shade above. We're going to connect our points right now. And we're using a solid line. And make sure you put your arrows at the end of your graph to indicate that it continues. And now we need to shade above because it is greater than or equal to. And this is what we will end up doing. And also label your area. I'm going to write y is greater than or equal to 2x minus 3. And I'm going to choose anywhere within the shaded region as one of our possible solutions. So I'm going to choose this point right here. One possible solution, 2, 6. One thing I'm going to say to you, because we're dealing with an inequality that has half of the equal sign underneath it, meaning it is either less than or equal to or greater than or equal to, we can choose a possible solution that is on the solid line. But we cannot do that when it's simply a greater than or a less than. So I could have also chose this point, which is 4, 5, only because it is on the solid line. And you cannot choose nothing on this side that is not shaded. The third inequality that I'm going to graph today is y is less than -2x plus 3. Once again, we have to identify our slope. Our slope here is -2. Our b is 3. This is our b. So we are going to start at 3 and we are going to go down 2 over 1 or up 2 to the left 1, up 2 to the left 1. Now, the next thing that we can identify from this is that because it is a less than symbol, we need a dash line. So I need a dash line for this. So I need a dash line that's going to go in between for this particular problem, and I can do this. Also, because it is less than, you're going to shade below. I'm going to shade below here. Notice I'm not stopping here when I'm shading. I'm coming all the way to the end of the grid line, all the way to the end, all the way. And I'm going to label that area as y is less than -2x plus 3. And I'm also going to choose one possible solution that would make my inequality true. So I'm going to choose the point of -2, 4 as my one possible solution. -2, 4. And I'm going to test this because you need to test it to see that if it is going to make the solution true. So I'm going to test this. So I have my inequality there, which is y is less than -2x plus 3. So y is 4, x is -2 and plus 3. So let's do the math. So -2 times -2 is +4 plus 3. 4 is less than 7. And is this true? Yes. Once you know that, yes, this is true, then you can say that the solution -2, 4 will make the solution true for this particular inequality. What if, hypothetically speaking, you decide to choose a point that is on the dash line as your possible solution? Let's test it. So let's test 0, 3. And I'm going to rewrite my inequality. Y is less than -2x plus 3. So my y is 3 here, and my x is 0. So I have 3 that is less than 0 plus 3. 3 is less than 3. Is this true? No. 3 is actually equal to 3. This is not true because the point that you chose, which is this point, is on the dash line. You cannot choose a point that is on the dash line for your possible solution. Only on the solid line you can do so. So you have to choose any point that is within the shaded region as your possible solution. Let's move on and graph the last one for you. Say, for instance, if I gave you y is less than 4 to graph, you know that that would be a horizontal line going across 4 on the y-axis. So your line would be a dashed line going across here because of your inequality symbol. You need a dashed line. And because it's less than, you are going to shade below. And you would simply go ahead and shade below. And once again, you would label this as y is less than 4, and you would choose a point anywhere within there. You can choose 0, 0. So if you choose 0, 0 as your possible solution, then you can test it. So we know that this is our x and this is our y. But in this case, we don't have an x. We just simply have y variable right here. So we're going to substitute our y, which is 0, and 0 less than 4. Is 0 less than 4? Yes, that is true. So this solution, 0, 0, will make the inequality true. There is an easy way for you to remember your less than or greater than. So you're greater than if you are a right-handed person, and that's your dominant hand to write with. This is your greater than symbol, which shows that your V is pointing away from you, and this is what the symbol looks like. And this is because this is a greater hand that you write with. This is your less than symbol because this is the less dominant hand that you write with. You rarely write with your left hand. So your V is pointing away from your body to your left. But this only works if you are a right-handed person. Obviously, if you are a left-handed person, it is not going to work. You have to think of someone that is right-handed, whether it's going to be a family member or a friend of yours, and think of what hand they write with, which is their dominant hand, what the V would look like. So that's an easy way that I can tell you how you are going to use that to remember what your symbol is going to mean and what it is looking like. I hope that this video has helped you tremendously, and you will know the 4 linear inequality symbols and what they mean, and you will also know when you will need to use a dashed line versus a solid line. You use a dashed line if your inequality is greater than or less than. You will use a solid line if the inequality symbol has half of the equal sign underneath that symbol. Thereby, if you have greater than or equal to or less than or equal to, you have to use a solid line as your boundary line. In terms of shading, if the inequality symbol is less than or equal to, you are going to shade below. Or in other words, you are going to shade to the left of that line if it is a vertical line. If the inequality symbol is less than or equal to, you are going to shade below. But if it is a vertical line, then you have to shade to the left because it is less than. However, if the inequality symbol is greater than or equal to, you are going to shade above that line. Or if the line is a vertical line, then you are going to shade to the right of that line. Obviously, if the line is a horizontal line, then yes, you will also have to shade above that line. So in summary, please know your inequality symbols and what they mean. Know when to use a boundary line based on your inequality symbol and when to shade based on your inequality symbol. I hope that this video has helped you tremendously and that you have learned a lot about inequality, which is one of the basic foundation in math. Learn the content well, practice it, because math is all about practicing so that you will be better at it and you will get a great grade. Thank you for watching and see you soon on the other side. Bye now. Cheers.